Hello dear students, very good morning to you all. In today's class I teach you last experiment from computer programming lab, that is experiment number 15. First I read the aim given by the university for you so that you can understand the program whichever I explain to you. This is what the aim given by the university. Implement recursive functions for binary to decimal conversion. First of all, what I do you know, I explain you the theory related to this program so that you can understand this program so easily. Already in the theory you learned what are recursive functions. Can you tell me what is recursive function or what are recursive functions? Yeah, your answer is correct. A function that calls itself to do specific task is called recursive function. That means a function is not calling other functions. Instead of calling other functions, that function is calling itself. That is what we call recursive function. Now what you need to do you know, you need to write one recursive function. That recursive function you need to call in the main C program to convert the value from binary to decimal. First of all, I teach you the theory how to convert the value from binary to decimal and decimal to binary, so that you can understand this program so easily. As you know already, computers know only binary language, that is machine level language, that is zeros and ones. Now what we do, we write one program to convert the value from binary to decimal number. See, here I have given the list. These are all decimal numbers: 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 and so on. As you know already, binary equivalent of 0 is 0 only, binary equivalent of 1 is 1 only, binary equivalent of 2 is 10, binary equivalent of 3 is 11, binary equivalent of 4 is 100. Then how to convert? See, here I have explained for you. Now we have a number like 9. How do you find the binary equivalent of 9? One simple calculation you have to do. What is that? Do you know? Divide that number by 2. 2 4s are how much? Yeah, very good. 2 4s are 8, remainder is 1. 2 2s are 4, remainder is 0. 2 1s are 2, remainder is 0. 2 0s are 0, remainder is 1. And pick these values from bottom to top. 1001 is the binary equivalent of the decimal number 9. I hope you have understood. Very good. One more we try. Can you find the binary equivalent of 13? Yes. Divide that value by 2. 2 6s are 12, remainder is 1. 2 3s are 6, remainder is 0. 2 1s are 2, remainder is 1. 2 0s are 0, remainder is 1. Pick these values from bottom to top. What is the binary equivalent of 13? 1101. Now cross verify. Really is it equivalent to this binary value? How to check? That one I explained you. Now you have to write one program to convert it from binary to decimal. Just I explained for you decimal to binary. How to convert it from binary to decimal? Now 1001 is really equivalent to 9. That one you need to check. How to check? Multiply all these binary numbers with 2. Multiply this one with 2 raised to 0. Multiply the second digit with 2 raised to 1. Multiply the third digit with 2 raised to 2. Multiply the last one with 2 raised to 3. Then how to solve this? Very simple. 2 raised to 0 is 1. 1 into 1, 1. 0 into any number will become 0. 0 into any number will become 0. 2 raised to 3 is how much? 8. 8 ones are 8. 8 plus 0 plus 0 plus 1. What is that? 9. Yeah, we got the correct result. Decimal equivalent of 1001 is 9. Yes, we got the correct result. Cross verify the next one. Can you find the decimal equivalent of 1001? Yeah, it is very easy. Multiply the first one with 2 raised to 0. Multiply the second one with 2 raised to 1. Multiply the third one with 2 raised to 2. Multiply the last one with 2 raised to 3. 2 raised to 0 is 1. 1 into 1 is 1. 0 into any number will become 0. 2 raised to 2 is 4. 4 into 1 is 4. 2 raised to 3 is 8. 8 into 1 is 8. 8 plus 4 plus 0 plus 1. That is what? 13. I hope you understood. How to convert the value from binary to decimal? Multiply each digit with 2 raised to powers like 0, 1, 2, 3 and so on. Summation of that one will become our decimal value. Now you need to assign this work to a computer. Then how to assign this work to a computer? That is what the lab experiment. I explain the program for you. Already in the aim, university has told us that you have to make the use of recursive function. Look at this very simple program. This is what we call user defined function. This is not a simple function. This is a recursive function. Because the name of the function is decimal, because we convert the given value into decimal value, in this decimal function only decimal has been called. Because of this reason, this is what we call recursive function. Means this function calls itself. How many times it calls? Till that n becomes 0. Whenever the n becomes 0, it returns 0. How this works I explain. No need to worry. In order to write this program, you need to add standard input and output header file. Not only this header file, you need to add math.h also. Do you know why we are using math.h? Because you need to find 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3. Then how to find? We use power function from math.h. That's why we need math.h. This recursive function we are calling inside the main function. See here, decimal come here, take the binary value, give me the decimal. This function takes the binary value, this function gives us the decimal number. That is what we are printing. Okay, and one more thing is very important here. We are using the variables of which type do you know? We are using long integer. Why do you know? Already we know the storage range capability of integer value. Can you tell me the storage range supported by integer value variable? Yeah, integer variable will take 2 bytes. 2 bytes means how many bits? 16 bits. 16 bits means what? 2 raised to 16. 2 raised to 16, how much can you tell me? Yeah, your answer is correct. 2 raised to 16 is 65,536 divided by 2. We get the range from minus 32,768 to plus 32,767. That means if that variable is an integer type, we can store a value which is maximum 5 digits. We can't store a value more than 5 digits, or the value must be in this range. Okay, minus to plus. But we enter the binary value like 1, 1, 1, 1, 1, 1, no, that exceeds 5 digits. That's why we need a variable that supports more range. That's why we go for long integer. I hope you understood. If you are working with long integer variables, you need to make the use of format specifier like %LD. That's why we use long integer variables. Now I explain the program for you. In order to write this program, we need one global variable. As you know already, what is global variable? Do you know? That variable can be used not only inside the main function, you can use within any of the user defined function. That is what we call global variable. In this program, recursive function we are writing means we are calling the decimal in the decimal only. That's why here first time I value is 0. Every time first I calculate 2 raised to 0, next I calculate 2 raised to 1, next I calculate 2 raised to 2, 2 raised to 3, 2 raised to 4. Here you can see I plus plus we have written. Here we are using it as a postfix operator. Here we are using it as a postfix operator. That means first I value will be utilized, afterwards that will be incremented. 2 raised to 0, 2 raised to 1, 2 raised to 2, 2 raised to 3, like that it works. That's why we need one global variable. I hope you understood. That's why what we do, we start a program by including standard input and output header file as well as math.h. Next we have taken one simple global variable. Afterwards what happens do you know? Here whenever the n becomes 0 it stops. See here I explain how this program works. Let us give the input as 13 only, not 13, 1001. Already we know what is the decimal equivalent of 1001. Just only we solved it. What is the binary decimal equivalent of 1001? That is 9. Now how this works I explain to you. Let us assume the given input is 1001. That will be stored in which variable do you know? That will be stored in binary variable. That will be stored in binary variable. See here 1001. Now this is having 1001. That is what I pass to the recursive function decimal. Now that will be transmitted to n value. What is the n value? 1001. Whether is it equivalent to 0? No. No means what we do you know? We extract the last digit from this binary value. How to extract the last digit from this binary value, do you know? Already you know. We use the mod operator. 1001 mod 10 means we get the remainder. That means 1 we get. 1 into 2 raised to 0. Yes, first digit we multiply with 2 raised to 0. Next you have to reduce one value from this and call the same function. 1001 divided by 10. 1001 divided by 10. That means what happens, do you know? 100.1. Both are integer. It gives us only integer part. That means I call the same function with one reduced digit. What is that? 100. 100 mod 10. 0. 0 into 2 raised to 1. Yeah. Next 100 divided by 10. 100 by 10 is 10.0. 10.0 means 10. Third time I call with 10. Again 10 mod 10. 0. 0 into 2 raised to 2. Again 10 by 10. 1.0. 1.0 means 1. 1 I pass. Whether 1 is equivalent to 0? No. 1 mod 10. 1 mod 10 is 1. 1 into 2 raised to 3. So and so. 1 upon 10. 1 upon 10 is 0.1. That is what the 0. That means what happens, do you know? Whenever this n becomes 0, it returns 0. That means first one is something is waiting here for the results. First time 1 it was given, no? 1 into 2 raised to 0. It was waiting for the input. Next 0 into 2 raised to 1 plus. Next what happened? Okay, just once again I explain for you this how this recursive function works. First time I call this recursive function with 1001. Whenever you pass 1001, whether is it equivalent to 0? No. That means from 1001, 1 we extract. 1 into 2 raised to 0. See here, 1 into 2 raised to 0. Then 1001 will become 100. 1001 divided by 10. That is 100.1. That means we call a same function with one reduced digit, 100. 100 is equivalent to 0? No. From 100 last digit we extract. What is that? 2. That is, what is that? From 100 last digit 0. 0 into 2 raised to 1. 100 becomes 10. 10 is equivalent to 0? No. From 10 we extract the last digit. What is that? 0. Once again 0 into 2 raised to 2. From 10 will become 1. We are passing 1. 1 is equals to 0? No. 1 more 10 is 1. 1 into 2 raised to 3. Then 1 upon 10, 0.1. We pass 0. 0 is equals to 0? No, returns 0. It returns 0. Means actually machine is waiting for the inputs output by previous call. Now machine will evaluate all those things. Means 2 raised to 3 how much? 8. 8 into 1, 8. 8 plus 0, 8. Next 2 raised to 2, 4. 4 into 0, 4. 2 raised to 1, 2. 2 into 0, 0. 2 raised to 0 is 1. 1 into 1, 1. 1 plus 0 plus 0 plus 8. What is that? 9. This function returns 9. What is that? 9. 9 is the binary equivalent of 1001. That will be stored in answer. That is what the machine will print. I hope everyone has understood. In order to write this main program, we use one bin variable, one more answer variable. Of which type? Long integer. We read the binary value and we pass to that function. That function will give us the decimal number. That is what we are printing. This is what we call recursive function. This is what the global variable. We use how many header files? 2 header files. See the output. Whenever we run a program, we get the message, enter a binary number 1001. What is the decimal equivalent of 1001? Decimal equivalent of 1001 is 9. Take one more output, enter a binary value. I enter 1101. Decimal equivalent of 1101 is 13. In journal, you write minimum 2 outputs like this. In journal, you need to note down the aim, next write the program, next write all possible outputs. I hope everyone has understood. Thank you. Have a nice day. Take care.